Hello, and thank you for joining us today for today's webinar with GeicoTaikisha. I'm Nick Holt, editor at AMS. The topic for today's webinar is the paint shop of the future and how it can meet the needs of a rapidly changing automotive industry. For this presentation, I'm joined by two experts from the company, Luigi Lazzari, Vice President for Sales, and Niccolo Mariotti, Sales Proposal Engineer. In this session, Luigi and Niccolo are going to look at how to achieve zero CO2 free emission processes and the use of analytics to improve paint shop efficiency and the need for flexibility in production processes, while also providing Geico's perspective on how the industry will look in 10 to 15 years as a result of these trends and their vision for the paint shop of the future. Before we begin, I'd like to invite the audience to send some questions for our presenters to pick up in the Q&A session at the end of the presentation. And you can type these into the chat box in the lower right-hand side of your screen. Also, if you experience any technical issues during this session, please use the chat box to let us know, and our team here will try and fix it. So with that, and we're just going to start with a short video, I'll hand over to Luigi and Niccolo to start the presentation. Thank you very much.
Okay, good afternoon, everybody. Thank everybody for joining this webinar, where we as Geico would like to give you a hint of what our ideas, concepts, and thoughts that has been developed by us in order to reach the goal of the sustainable paint shop of the future. Sustainability means different target actually. What we would like to share with you today is what the footprint in terms of CO2 emission we would like to reach with our paint shop solution in the next future, and together with that also what improvement of the overall paint shop processes and projects could be done again in the years to come. I will introduce myself very quickly. I'm Luigi Lazzari and I'm Vice President Sales here at Geico. So let's start with the first slide of the presentation. So this slide represents a little bit the past, what we have done so far in terms of sustainability and what at the same time we want to do for the next future. This is an important slide because it shows the continuity between the project that we have developed in the last 10 years and the one that we are going to develop in the next years. As you can see here in the slide, we have two key points. One is the one that is called Energy Independence Day, and the other one that is the CO2 free day. The Energy Independence Day has been the target and the goal that aimed our project in the last 10 years and all the, let me say, innovation processes that we have developed in-house in the last period. This important milestone was meant to be the day when a paint shop could be self-sufficient, let me say independent from any energy grid, and to be able to work without the help of any external energy sources. We started in 2005 with a situation, an average situation in terms of consumption that was with a value of around 900 kilowatt hour per body at that time. Then through the development of different products and solutions, we've been able in 2017, so 3 years ahead of the original goal that was June 16, 2020, to reach the Energy Independence Day. At that date, we have been able to develop a paint shop project with an average consumption of 270 kilowatt hours per day. This huge reduction in energy consumption also allows us to look at the situation of the energy providers and trying to get all the sustainable energy sources that can be available in order to have a self-sufficient paint shop energy-wise. Now, the next step, that is the one that we have launched in this year, is to reach what we call CO2 free day, with the goal to reach this objective by 2027. Let's go ahead with the next slide, where, let me say, also connected with our goal of reducing energy and the CO2, we can show the different area where we have worked. Actually, we have worked on every single step of the paint shop process, starting from pretreatment, where we have reached the 86% in terms of energy saving. and moving from the pretreatment to the other process steps. Electrocoating is, of course, another very important process inside our paint shop, where a lot of development has been reached, again, reducing the energy by the 23% of the original value. Let's see if... So if we take the pretreatment and electrocoat as a whole, what we call, let me say, corrosion protection process, we have moved from an original consumption of 80 kilowatt-hour per body and 26 kilowatt-hour per body in pretreatment, respectively in pretreatment and the electrocoating line. Together with that, with this energy consumption, we've had the chance, the opportunity to lower both operating cost and footprint. This also has had an impact onto the overall management of our plant, of our system, and also to allow a cleaner process, meaning with cleaner, let me say, lower contamination of the bath due to drag out from one pretreatment or recoat stage to the other one. This has been then, let me say, realized working on the conveyor systems, for which we have developed the J-Jump family and the Lean Deep family of conveyor system. And these have been the target that we have achieved. So 11.4 kilowatt-hour per body in the pretreatment, thus with a reduction of 86%, so a huge reduction, and 20 kilowatt-hour per body in the e-coat with a relevant reduction of 23%. Now we move to another process step, that is the sealing line, where the original value when we started our work was 58 kilowatt-hour per body. And through the implementation of different improvement and product, we've been able to go to 15.7 kilowatt-hour per body, meaning the 72% reduction in the energy consumption. Again, also for this process step, different goal has been reached as a footprint, for example, reduction. The key point in our overall Energy Independence Day project has been the one dealing with the spray booths. Actually, spray booths, when we started our analysis, was by far the part of the process step with the highest consumption, 346 kilowatt-hour per body. So we have focused a lot of efforts in order to reduce the energy on this process step. And the second process step by importance has been the one dealing with ovens and coolers. We have been able to dramatically reduce by more than 50% the consumption inside this process step. So if we have an overall look at these last process steps, starting from sealing line up to ovens and coolers, what we have done in order to reach our target is to work onto the ventilation, where we have, let me say, included a an overall concept of the ventilation, not taking into account only the paint process itself and the paint equipment itself, but also the building ventilation. So by integrating the two different aspects of the ventilation inside the paint shop, we've been able to reduce the energy. The process that has been used in the last year by deleting the primer coat allowed us to reach a considerable reduction in the energy. But the key point, I would say, has been the dry scrubber solutions. Dry scrubber solution means at Geico, two different type of scrubbers, the dry spin and the dry car. The both scrubbers, they are able, as they are called, as a matter of fact, dry, not to use any water, and this allows us not to have a huge amount of energy to be used to remake up the air when we exhaust the air from the booth, thus allowing us to recirculate the air and then to reduce to a minimum the quantity of fresh air and consequently of energy. Then other important products in this field that we have developed are some smart design solution aimed at reducing the energy, not in terms, let me say, of absolute value, but in case when we are in a condition where the production capacity that is requested to the installation is not the one for which the installation itself has been designed, but is lower. So in that case, you know that there is a lot of inefficiency in terms of energy usage, but we have developed some very flexible system in order to reduce this impact. And then looking at the, let me say, 4.0 industry, we have introduced some intelligent system, I would say, inside the oven, where we are able, with actual measurement of the solvent content inside the oven, to be able to manage the quantity of fresh air that is needed to wash, I would say, or to keep the solvent content inside the oven inside the desired value. In terms of energy, when we started in this field, we had a consumption of 707.3 kilowatt hour per body, and nowadays we are able in these process steps to have an overall consumption of 204 kilowatt hour per body, which means a reduction of 71% in terms of energy consumption. Then if we move up towards the end of the process step inside the paint shop, and we talk about control and finishing, even if this is not, let me say, the part of the process which is, let me say, energy demanding, we also have optimized the solutions, and also in this field we've been able to reduce the energy by 40% from 5 to 3 kilowatt hour per body. Then, if we move to the touch-up area, where we have also some process steps which are similar in terms of energy consumption to the main spray booth, we've been able to reduce the energy consumption per body from 13 kilowatt hour per body to 8 kilowatt hour per body, thus achieving a 38% of energy reduction. So again, if we summarize the last process steps. What we have here introduced is due to the technology of filtration, overspray filtration and so on, to achieve a higher air recirculation in the spray booth. We have introduced also our AGV system, which have been fully developed in-house, moving towards a modular layout, very flexible, and using the booth only when they are really needed. As far as 4.0 industry items are concerned, we've been able also to introduce our GeicoTaikisha system, that is the system which is able to automatically detect the defects onto the system and to give feedback to the plant managers, to the paint shop managers, to be able to collect data information from the field in terms of quality of the coated surface and to turn such an information into actual actions to be done onto the different process steps in order to improve the efficiency of the paint shop. In this area, our achievement has been the reduction of 38% of the energy, moving from 18 kilowatt-hour per body to 11 kilowatt-hour per body. So, at the end of the day, this is the overall resuming table with the reduction that we have been able to achieve in the different field, in order to be able then to introduce the renewable energy sources and thus to start our, let me say, path towards not only the Energy Independence Day, but towards the CO2 free day. Just to resume, the target date 2027, and we, as we have done for the Energy Independence Day, we will put all our efforts even to anticipate that date when possible. The concept of the CO2 free day is to work not only on the reduction of the CO2 coming from the reduction of the energy consumption, but also not to have inside the paint shop itself, inside the processes that are present in the paint shop, any CO2 production. This is, let me say, the additional point that we are adding to our original project. Of course, this CO2 free day comes from the need which arises from the market on one side, because all the OEMs, they want to be as green as possible. This is a very important asset that now is also considered in the overall also corporate social responsibility of each individual company. But also, of course, it is needed because regulations about environmental impacts coming from human activities become stricter and stricter. So, what is then the concept that we would like to apply for our paint shop of the future? Mainly is to move from the sources of energy that uses gases or oil or whatever is this kind of energy sources to pure electric energy sources. This means that the energy that will be required for the paint shop processes will not come anymore by gas, hopefully. We have to work on two different process steps also here in order to reach this target. One important step is the one dealing with the pretreatment process. The other one, of course, are ovens. All the systems that are needed for the polluted air abatement system, and then all the heating stages that are needed both for ventilation or for some specific process that some OEMs they do use in their process. So, if we go to the pretreatment and decoat, where we need to work. Conventionally, today, pretreatment heating stages, they do use hot water to heat up the bath and, let me say, all the chemicals that are needed to perform such a process. And such hot water is generated normally from a boiler with a gas burner. So we have some options which are available to us to be introduced in order to eliminate the gas source, and those options can be or using electric heated boiler in order to produce the hot water, or to have a direct electric heat exchanger at every single point where the process needs to have some energy to warm up or to keep at the right temperature the different process steps inside the pretreatment and decoat. Also, we can have other technical solution in order to heat, and here you have in this slide some very simple schematics that can be used to heat, for example, degree stages with direct heating, or a phosphate stage in case process is with phosphating, because if it is with thin film technology, we don't even need this kind of schematics of solution to be installed. You can have then a comparison table you can see in our slide where we can see what is the reduction that we estimate in terms of energy when we move from gas type, gas powered, I would say, hot water production system to electric power. Then we move again to the ovens, because ovens, of course, they are a huge gas eaters, I would say, huge gas users, and such fuel, of course, is one of the key root cause for the CO2 footprint value that we have today. Again, here the solution is like it is illustrated in the picture in the slide, to use heater boxes which are directly fed with electric power. We have the possibility to install different size, different capacity electric air heaters from 1 kilowatt up to 1 megawatt. And they are very, let me say, simple to be installed, very clean, and of course, very easy to be maintained when we, of course, make a comparison with the existing equipment, the equipment that are normally used nowadays. Same type of concept we do have for spray booth ventilation, where again we require heating stages which are commonly fitted with heat exchanger. Then we can use hot water or direct gas burner, but anyway, in both cases we could have some impact in terms of CO2 footprint. Of course, in case we use hot water, we can use hot water production system which are fed with electric power, or in the other end. So in this case, let me say the air supply unit itself does not change, or we can implement a direct electric powered heat exchanger inside the air supply unit. So if we want to make a wrap up of what we have so far discussed about and illustrated about the concept of the fully electric paint shop, we could have these resuming tables which shows the fact that we could just, let me say, work with electric power, so no gas anymore, no oil anymore, and water. Water is another key point that needs to be addressed, but already with the current solution, we are able to reuse and recirculate most of the water that are running, let me say, inside the paint shop itself. Of course, all this system, different products that we have seen spread inside the paint shop in different areas, in different process steps, can be furthermore optimized by using heat recovery system. This heat recovery system usually, of course, at the beginning, this is something that we normally discuss with our OEMs. They, of course, increase of a certain value according to the complexity of the system and the extent of the system, the value of the investment. But on the other end, we have, and our OEMs can have big advantages in the operational cost, thus allowing them to anyway reduce their day by day or year by year consumption cost that they do have in running the paint shop. Of course, we have other options. We have talked about PT and ED. We can make use of heat pump or chiller with heat recovery in order to, let me say, balance the need for heat and the need for chilling units with this kind of equipment that are able to recover a part of energy that is produced to chill the water in order to be reused to warm some pretreatment stages. There are, in terms of, again, further improvement, other concepts that can be introduced. For example, in the ovens, we can work onto a skidless system, for example, in order to move the pure body inside the oven. So we do not need, in that case, to heat up, let me say, a system or a component, I would say better, that is not actually the body itself, but it's something that is just used to carry the body. So by simplifying the conveying system, we can reduce the energy and increase, of course, the efficiency in the oven. We can implement, and we already do it, a direct evaporator system in the intermediate cooling and flash off areas. Or we can also work on some, let me say, less technological, I would say, solution by simply improving the oven insulation with a different concept, by increasing the thickness of the insulation matter itself, or by using new type of insulating material, which can be of, let me say, of an advantage, can be an advantage for the customer, both in terms of energy efficiency, but also in terms of overall clean concept of the oven through all this life, his life, including the final disposal after the usage. Okay, we also work, of course, onto the configuration of the spray booth. We have developed, for example, the GI system, which is a booth which is provided with a robot that does not need a conventional 7-axis, so a rail, which means dirty, which means having some footprint of the booth, but to have a 6-axis installed on the wall, reducing booth width not only, but I would say the booth footprint as a whole. And then, of course, direct evaporating system like the one used for the ICFO. Okay, with the robots system, we can have different advantage by changing the type of robots. So you can see from this slide how we can reduce the width of the booth and consequently the quantity of air that is necessary, and together with the quantity of air, of course, the quantity of energy. Last but not least, we have the full field of the renewable energy systems, for which we have developed concept in order to use the solar energy in different way, by using both solar thermal modules, or let me say the direct transformation of the solar energy into electric power. As the paint equipment, the paint shop process equipment itself, so of course, they do need a box where to stay in. It is very important how we design also the box itself, so the building. And for this reason, we strongly believe and we strongly work into an integrated design of the building and of the process equipment itself. Because by approaching in this way, in an integrated way, the design of the building and of the process equipment together, we can have a lot of opportunities to reduce energy. We have talked about, for example, shop ventilation, but also we can have air conditioning only when it is required by the process, so to reduce, let me say, the amount of energy used for the building, and of course to work also on the lighting level of the different part of the building, because as more automation we will have and we will introduce inside the paint shop, the less lighting value, looks value we will need inside certain areas of the building itself. So, next step is what we call a circular approach to the process inside the paint shop. This means that we need to take care also of the CO2 coming from all the activities that are around the paint shop process. There are the filters disposals, the scrubbers, so anything that or any material that inside the paint shop is used and cannot be today recirculated, reused in some way. This is a key point where we need to focus in order to lower again the CO2 impact and to move with a bigger step towards the let me say fully sustainable paint shop. There are last but not least some alternative energies that are, let me say, now available with let me say a better comfort, I would say, on the market, like for example green hydrogen, and this is also one of the energy sources we are looking at in order to see which kind of advantage we can have by introducing this kind of energy. So I will leave now the stage, I would say, to Niccolò to explain a little bit in a different way our concept for sustainable paint shop.
Thank you, Luigi. So my name is Niccolò Mariotti, and my role is a sales proposal engineer. So this part of the presentation will be a little bit more futuristic, in the sense that we will try to provide you our vision of the automotive sector and how it will evolve in the next coming years. In my opinion, the best way to understand the true scale of the transformation is to provide you some figures and facts. First of all, the autonomous vehicles that are registered just in California traveled approximately 3.2 million kilometers, that are something like 2 million miles for the US, in autonomous mode on public roads. And if you think that this number is huge, this figure has seen a decrease from the previous year, 2019, when it reached 4.5 million kilometers, approximately 2.8 million miles, before the pandemic outbreak. And also, if you think, Google has transformed our ability to get to these facts. Some of you probably already finding out whether anything I said is true, but trust me, this is true anyway. If you think just these two facts alone are representative how our society is changing very fast. So we are getting news of words such as shared mobility, autonomous driving, as well as circular economy and waste recycling. So let's start from here. What kind of changes are coming and how they will affect traditional vehicle manufacturers and suppliers, potential new players, regulators, consumers, market. In order to do so, the first step is to assess which are the new market trends that are driving these changes. First of all, we have to make some assumptions, define the boundaries of our analysis, and identify the constraints. So the first boundary is the time frame of the concept. We are thinking how cars will be industrially painted in 2030. In 2030, sorry, in a way that is achievable and feasible, employing emerging technologies that are now only concepts under testing. And how can we bring this to be a key success factor for our customers? So the introduction of CO2 emissions targets and correlated penalties has reignited the conversation with an even stronger focus on weight reduction as a lever to minimize the fuel consumption of our vehicles. The trend of ever-increasing weight for cars has been curtailed in recent years through the increased use of plastic, for example, for fenders and door in the new Smart, and the edge in the new Toyota Corolla, and improved steel alloys for the chassis. Cost considerations have so far often prohibited the use of lightweight materials, but penalties have resulted in increasing the lightweight share that is forecast to grow from 30% to 70% by 2030. And in this way, high-strength steel has been considered as a lightweight material. One of the most important parts is related to the electrical mobility. A McKinsey study says that automotive industry will see more disruption in the next 10 years than it has seen in the last 50 years. Just yesterday, the European Union proposed an effective ban for the sale of new petrol and diesel cars from 2035, aiming to speed up the switch to zero emissions electric vehicles. The clean air we have enjoyed and we have experienced during lockdown seems to have shown the true scale of transportation pollution and how electric cars can play an important role to reduce it. The Tesla Model 3 is already the best-selling vehicle in California, as it is already in the less representative market of the Netherlands. GM is launching a new electric delivery van in a bid to prevent Tesla taking over that market, and announced plans to introduce at least 20 all-electric models in all categories by 2023. In the same sense, also Amazon is working to add 100,000 Rivian all-electric vans to its delivery fleet. Last March also, Volvo Cars committed to become a fully electrical company by 2030. These are some recent examples of how the car manufacturers are already committed to bring electric vehicles on the market. And we are also seeing startups, market caps, on par with that of several global auto players that are already on the market since several years. This is based on the expectation of new car models coming soon on the market, exploring new mobility business models and their economic and consumer viability. Several countries, such as Spain, France, Germany, Italy, have recently announced new plans to promote the sale of electric vehicles, increasing incentive for their purchase. Time to market, for this reason, is becoming crucial, and so the time reduction for the development of our paint shop. Squeezing the delivery time from 18 to 22 months, that is what we had usually in our previous experience, to 10, 14 months, and even shorter. In this way, modular and smart design can play a huge role in achieving this target. Equipment can be assembled directly in workshops, shipped in one piece, leaving marginal activities to be carried out on site. These have several important benefits, such as reducing manpower on site, improving fabrication quality, reducing installation time, and it has also an important effect on the health and safety side, since there will be less people and activities to be carried out on site. So it is also easier to manage the construction site. Reduction in emissions does not only apply to the products, for example, in our case, vehicles, but also to manufacturing processes. Even if, at least in the EU, we have seen a reduction in the industrial emissions in the last 30 years, globally, the trend is continuously rising. The widespread view that fossil fuels are dirty and renewable energies such as wind, solar, and even the electric vehicles are clean has become a fixture of mainstream media. In the same way, factories that rely on renewable energy sources are starting to take advantage of this fact to improve their reputation on the market. The pandemic has caused a big shift in consumer behavior, with more than a third of EU citizens saying that they are buying products from companies with strong environmental credentials. A further 4 in 5, so 80% more or less, say that they are planning to purchase goods and services from businesses that they know they've made a concerted effort to be environmentally friendly. So humanity is becoming more and more aware about the impact we have on our planet, and thus, as GEICO, we are pushing the development of a plant that can be CO2 free, eliminate waste as much as possible, and minimize water usage. The ability to collect data can give the possibility to improve the performance of the manufacturing processes by increasing the efficiency and reliability of the plant. Mature analytic systems can today process large quantities of data and offer various analytic methods. They can identify potential faults in advance and provide opportunities to develop suitable countermeasures through early signal and anomalies detection. Having global control of the production process and storing all the data arising from it makes it possible to locate anomalies. Data can enable the early detection of faults in production in order to anticipate problems before they can occur, applying machine learning technologies. A history of activity is stored, creating traceability and the potential and the possibility of analyzing whether any of these data shows a change. Currently, most factories rely either on maintenance schedules based on preventive rules or on reactive response to unexpected failures. Predictive maintenance, on the other hand, bases maintenance on big data analytics and artificial intelligence, which are used for operational simulation that often led to insights that may be otherwise masked. It is also crucial to understand the impact that these trends can have on the people that have to operate and run the plant. With the right notification systems, staff are instantly aware of issues that require immediate attention, especially when they are not present on site. In this way, problems can be resolved quickly, thus minimizing production downtime and without the need for travel. The implementation of software accompanied by the knowledge of the staff is the perfect synergy for efficient problem solving. The capability to adapt production output to meet the market needs is also a key success factor. Flexibility is also measured in how fast a new car model can be introduced in the plant and so be on the market. With the more complex and diversified products to be dealt with, simplifying production processes can be a path to success. So we have shown here how the automotive industry is evolving and how we want to meet these future needs, building our Sustainable Paint Shop 2030.
So thank you for your attention. I hope we've been able to give you some impulse, let me say, some good reason to ask questions in order to also allow us, in case you want to give you some more hints or some details on some of the topics we have illustrated during our presentation. So we are here available for you all.
Thank you both. That was a fascinating presentation and some really impressive figures in the reduction of energy usage across the whole paint process. I was really surprised, and it's really interesting to see how it's not just one thing. It's a lot of development in a lot of areas. You clearly, obviously, but you've identified some key areas where you could save some energy, and obviously heat exchange and recycling the heat from the system was a key one. We've probably only got time for one, maybe two questions. But what for our audience, all the questions that have been sent to us will be passed on to the team at Geico, and they will be able to respond probably in more depth regarding your queries to the presentation. Just picking up, there's a question in here. Just get that one out. Yeah, I mean, you mentioned, I think Nicola pointed out that the move to try and lightweight vehicles is we've seen quite a lot of multi-material mix in bodies. And obviously you were citing quite a lot of figures at the beginning of savings at various stages. The question here, was this based around mainly on a steel body operation, or were you including any kind of mixed material in that? And does it differ quite a lot?
Niccolo, you want you to?
Yeah, basically in our idea, the paint shop that we are developing that we are imagining for the future is of course a paint shop that can treat different types of materials, such as plastic parts, such as aluminum, steel alloys, and something like that. So of course, what we have done is to analyze the trend that these materials are used in the automotive industry, and what we are seeing is that, for example, the carbon fiber material it remains just for very expensive cars that probably will not affect too much how the paint shop will evolve in the future. So our core analysis was based on the most common materials that are steel alloys, aluminum, plastic parts, and that's it.
I would add one thing to what Niccolo said, because actually this kind of question opens the way also to a different way to see the data that we have shown that we have reached from 2005 up to 2017. They are based on a steel body. This is This is the point. Of course, if on one hand complexity can add issues and different problems to be faced and solved, on the other hand, as it happens anytime, these are also opportunities, because this kind of material needs different processes and also different type of equipment, which could bring a further reduction of CO2 footprint inside the paint shop.
Another quick question here. We've got time for one more. There are quite a lot of questions here, and I think they probably deserve a bit more of an in-depth response to them. As I say, so they'll be passed back to you guys to follow up on. You mentioned, someone's picked up here, you mentioned use of solar, using solar power for various parts of it. And the question here is kind of, where do you see, what's the extent of using solar power in powering or supplying energy to I'm assuming directly via solar panels around the plant, maybe. But where do you see the extent of that going with the paint shop?
Well, as far as the renewable energy sources, first of all, we have done and developed a software together with the main university here in Milan, Politecnico di Milano, which is called J-Power. This software enables us to find the best mix of energy to be used, including renewable energy sources, according to the site where a plant will be installed. Because of course, the availability of the different energy sources, because we are not talking only about solar, we have mentioned solar, but we have wind, geothermal, so we can have a huge variety of renewable energy sources. And we have developed this tool in order to have always in every site of the world the best mix of energy to be used. This is a key point, because in the end, what you do and what you think about your concept must be, as Nicolò mentioned in his presentation, achievable. Something that you can do, not only something that is for sure nice to see, nice to think about, but if you are not able to turn it into reality, then it is just a concept. They can push you, it's important, because push you to look for a new solution, but if you do not find the right compromise between reality, what is available, and concept, you will never be able to provide actual solutions.
And looking at the scope of the different ways you've looked to reduce energy consumption, the key word here is optimizing, I'm guessing, because and the word, if I speak to anyone in the automotive industry, wherever it is in the plant, they're talking about optimizing the material mix, everything, and it's around with us, but it's key. And as you say there, it's the balance of various factors being brought in. We've got some great questions for you. It's a real shame we didn't have a bit more time to fire them back to you, but as I say, passed on to you, and you'll respond accordingly to our audience. So with that, I'd like to say thanks to you both for a really informative webinar. I know I've been to the Pardis Innovation Centre, so it's really great, and I know about some of the zero emission things from quite a while back, your ambitions to achieve this. So it's great to see these being realised and how you're doing it. So it's been really interesting. Thanks for that. As always, for the audience, the webinar will be uploaded to the AMS website, and you can access this in the future. And if any of your colleagues haven't been able to watch it today, they can watch it again on the catch-up. And you can access it via the Voice of the Industry link at the website. Thanks again for taking part with us, and we hope you'll join us for our next webinar. And with that, I'd like to say thanks to Luigi and Nicolò, and goodbye. Thanks very much.
Thank you, Nick, for hosting us.
Thank you very much.
Thank you.